Hi friends, yesterday we learned about arrays, boxes for numbers. Today we have strings. A string is just a fancy word for a chain of letters. But in Python, strings have a special rule. They are immutable. That's a big word that just means you cannot change them. If you have a train that spells CAT cat and you want it to spell BAT bat, you can't just swap the C for a B. You have to build a whole new train to see every letter. We just traverse it, which is like walking from the first carriage to the last. Next, hashing. Now let's learn the most important secret in coding, hashing, or we call dictionaries. Imagine I have 100 bags of chips. If I ask, is there a spicy chip bag? You have to look through every single bag. That's slow. But what if I had a magic book? I write the name of the chip on the one side, the key, and the cabinet number on the other, the value. When I want to find it, I just look at my notebook, boom, I find it instantly. This is O of one lookup. It's powerful because it stops us from doing nested loops, which is like looking through every bag over and over again. Next, look at this problem 1, valid anagram. Are these two words twins with the same letters? Instead of checking every letter against every other letter, we use magic notebook, HashMap. First, count letters in a word A, like A comes 3 times, N comes 1 time, G comes 1 time, R comes 1 time, and M comes 1 time. Next, subtract letters in word B from word A. If our notebook ends up with all zeros, they are twins. Next, problem number 2. First unique character. We walk through the word once and write down how many times we see each letter in our notebook. Then we walk through it again and the first letter that has a 1 in our notebook is the winner. He is the only one standing alone. Next, problem number 3. Longest substring without repeating. Imagine you are picking a team of friends, but no two friends can have the same name. We start a window. We add A, then B, then C. Oh, look, another A. We can't have two A's. So we slide the back of our window forward until the first A is gone. Using a set helps us keep track of who is in the window. Here set means a special notebook that hates duplicates. Next, problem number 4. Group anagrams. This looks tough, but it's just sorting. We take a word like TEA, sort the letters alphabetically to get AET, and use it AET as the label on the bucket. Any word that sorts to AET goes into that bucket. Simple, right? And the next, why brute force is a slow turtle? Why do we use these notebooks? Because without them, we are like a turtle checking every possibility. That's brute force, and it's very slow. With hashing, we remember what we have seen, making us super fast. Go try these problems now. Ask yourself, can a hash map make this faster? See you on the day 3.